Do you know how to work with databases index? It's a very important feature that could do the great difference in a performatic and in a non-performatic application. One query could take seconds to perform, and the others could be performed quite instantaneously. So the usage of index could create a great user experience to your application. So in this video, we are going to see how to handle these indexes, how to verify the existing indexes in a table, how to create a new index to match the criteria of some query, and how to identify, how to evaluate how performatic the index is. It's not difficult. We are going to see just a few sets of instructions that could help you in this proposal. So let's take a look here. We have this default table from MySQL that we can select here all actors from a table. And here we have almost how many rows? 214 rows here created. Okay. And we want to filter one specific record here, but not based in its ID, but based in its first and last name. Then we have here one filter by first and last name. So how? Of course it will work. We can write a select, make a projection for all columns, and filter with the where clause for the first name and last name columns. It will work, of course. We can perform this select here. But how good was selected executed? Then, for this purpose, to know this information, we can use the explain keyword. The explain keyword in front of one DML instruction, for instance, the select instruction, we can verify how it has performed, how many rows it had to evaluate it to give us this output. Okay, so we run again, but now with the explain keyword in front of it. Take a look in the columns we have been presented here. And one important column here is the rows. Why this column is so important? Because it has informed to us how many rows it had to evaluate to give us the proper result. It was almost all rows of this table. It has performed a linear search. It has row by row asking your first name is equal Chris and your last name is equal Redfield. No, okay, I don't take you. Yes, okay, you are in. So it's not non-performatic query. Okay, of course we have just a few records here. The time of execution of our query is quite irrelevant, but you have to process all rows in the table. If you have more rows, then time could increase. But independently of the size of this table, how many rows exist, our time for performing this operation could be constant and could be almost immediately. And for this purpose, we need to create one index that will match the criteria we are going to look with the where statement, that is the first name and the last name. For this purpose, we have to create one index using the create index statement. Then we have to form the name of the index we are going to create, in which tables are going to be created, and what are the columns that are going to be indexed together. If I want to filter by first name and last name, I have to index by these two columns. But before creating this index, let's experiment the show index statement that we can use. Show index from and then the table name. This instruction shows to us that currently we have just one index in this table, that's by the actor ID. So if I had created here, just for we have one example, let's see what's the idea of this record, 214. So if we perform this same select based in the ID to be equals 214, how many rows will be evaluated? Okay, just a moment. a no column ID. Okay, probably it utilizes another name. It should be actor ID probably. Let's confirm the column name. Exactly. Actor ID. Right. Now probably we are going to have the output and just one row was evaluated. Okay, one row because actor ID. Why? Just one row here, and here we have our rows of the table. It's because we have just one index for the actor ID column, right? So if we want to have the same performance with filtering by another columns, we have to create another index to be utilized. So we can create a new index with this statement over this table based on the first and last name. Just run this instruction. The index was created, and now let's ask to see the existing index again. So it gives us 3 rows, okay, but 2 of them representing the same index. That is the new one we have created that has the first name and then the last name in this order. The order is important, okay, so remember that. Okay, so our index was created, and now we are going to execute again this same select. Okay, of course it gives us the right output. The time is almost irrelevant, but let's explain and see the details over that. Look, now this select that's based on the first name and the last name also has evaluated just one row. So no matter if you have 1 million of rows in this table, the performance will not slow down. Ours just one row to be evaluated because it is indexed, right? So basically that. Just for end our video, let's see how to drop one index. So here we can show existing index. Look, we have 2 rows for actor name, but if you drop the index with actor name, we are going to drop the entire index. So these 2 rows will be removed. Okay, we have dropped the index, and if we run the show index statement again, we can see that that index exists anymore, and just the original one that created the index by the actor ID. Hope you have enjoyed this video. You can take this code as example. It's available to be downloaded with the link below in the video description. And thank you for watching.